Another important fact about the standard deviation is something called the empirical rule. Now, the thing about the empirical rule is that it's only available to use if it's bell-shaped. If it makes kind of this shape from graph number 2, then you can use the empirical rule. Some places or some books call it the 68, 95, 99.7 rule. Namely that 68% of your data is going to fall within one standard deviation, i.e. one below all the way to up one above. Roughly 68% of the data will fall in there. And then 95 within 2. So from 2 below to 2 above, 95% of values will be in there. And then from 3 to below to 3 below, above is 99.7. And past that, it's got to be the remaining 0.3%. So half of it's over here at 0.15. The other half is over here at 0.15. For our class, anything that's beyond 2 standard deviations is considered unusual, which would be less than 5%. So if it's got less than 5%, i.e. over here on the right, and or over here on the left, past 2 standard deviations, that's unusual. In manufacturing, they worry about 3 standard deviations. I don't know if you've ever heard of the 6 Sigma, I think it's called 6 Sigma quality control or something. 6 Sigma, why 6 Sigma? Well, because it's 3 below to 3 above, i.e. 6 altogether. So they'll say, like, we want our, I don't know, Tylenol filling machine to be no more or no less than 3 standard deviations away in terms of number of pills, that kind of thing. Okay? All right. And again, you can only use this rule if you've got a bell shape, if you've got a normal distribution, right? That's another word for it. Okay, so we're going to construct a normal distribution with parameters labeled and proportions labeled. I'm going to go grab that from the internet, and I'll be right back. Hold on one second. All right, here we go. All right, so never mind what program I'm using. Well, I'm using something called Snagit, if you want to know. It's a very simple program to use. Love it. All right, so I'm going to go in here. I grabbed a picture from the internet. And, of course, you will just draw it by hand. That's what I do most of the time. Oops, hold on one second. There we go. Now I got them all in there. Okay, so 64 is in the first section, right? 64 is in the middle right here, and then 61.25 to 66.75. You add on 2.75 over here, then you take away 2.75 over here. Matter of fact, I'm going to add little colors so you can see here. Hold on one second. There we go. So you can see 68% is this purple line right here. So from this line to this line, that's 68%, 61.25 to 66.75. And then I add on 2.75 more, and I get 69.5 over here and 58.5 over here. That's 2 standard deviations. And then 3 is the blue arrow from 55.75 to 72.25. Altogether, this is what you have to draw for this problem right here. There we go. It's involved, I know. But you'll be drawing it by hand. You won't be using a computer, most likely, to do it. However, if you want to, Snagit. Snagit's a nice economical program. It's available for free on a lot of campus computers, and it's awesome. All right, so what percent of women are between 64 and 69.5? Well, that's this section right here from 64 to 66.75 plus the next section from 66.75 to 69.5. So that'd be 34% plus 13.5%, which would make a grand total of 47.5%. All right, what about taller than 69.5? Okay, well, that's this 2.15 plus, I don't like the percentages they're using there. It should be 0.15. Hold on one second. There, that's better. Matches the percents that we were given by the author. And that's actually more correct anyway. Okay, so we want 2.35 plus 0.15%, which would make 2.5%. All right, what about the percent of women that are taller than 64? Well, 64 is the middle, so that would be 50%, right? Because half of the scores are above it and half are below it because it's symmetric. What about between 61.25 and 72.25? All right, I'm running out of time, so hold on. That would be 83.85% because you add up all the different sections, 34, 34, 13.5, 2.35. Are any results unusual? Yes. Taller than 69.5 because the percent there was 2.5%, which is lower than 5%.